All right, class, hopefully those post-tests went okay. Today we're doing simplifying exponents. This is the notes for the homework for tonight. Some of these you know already. For example, if you have something to a power plus something to a power, like x squared plus x squared, the only thing you can do is add them together. This is one of these and one of these, so we have 2a to the m. When you multiply the same base, you end up adding the exponents. When you raise a power to a power, you end up multiplying the exponents. When you divide, again, this is the same base, and you have different powers, you subtract the exponents. Anything raised to the zero power is just 1. A negative exponent does not make the problem negative. It flips it over. So if it's a negative exponent by itself, it becomes a fraction, and then it's a to the m, and it's a positive exponent. Now you can distribute exponents, but only over things being multiplied or divided, not added and subtracted. So adding and subtracting, again, not a good thing. It's like canceling with adding and subtracting. You can't do it. You can't distribute also. So we have a to the m times c to the m, and that's all we can do with that. And this can be a to the m over c to the m. You're raising both of them to the m power. So variables are always written in alphabetical order. Negative exponents are never left in the answer. That's important. Numerical answers and fractional answers. Write it out if there's 4 or less digits, and if it's 5 or more digits, leave it as powers. And I'll show you maybe an example of that for number 4. So let's evaluate the expression, give an exact answer. All right. So again, let's not use the calculator till the very end. I know that this is a power to a power, so I can multiply those and say I have 3 to the negative 8. Then I'm going to rewrite that because it's a negative exponent. Negative exponent flips it to the bottom, and I get 1 over 3 to the 8. So now you can type it in your calculator, type 3 to the 8th in, and you notice that it's a number with 4 digits, so that's okay. It's not too big. So the final answer is the fraction 1 over 6561. And you can type this in and check that. Okay. This one here, we distribute, well, we raise both pieces to the power of 3. And then you just do that. That's 125 over 512. And I think that does not simplify. No, it can't. Okay, so number 3. Number 3, notice you have 2 of the same bases. So if these are the same bases, when you multiply the same bases, you can add the exponents. So I'm going to say it's negative 2 to the 9 plus a negative 3, which is 6. Now remember, a negative number is not a negative exponent. So that's just, a negative number. You're not flipping it here. So you multiply, you raise this to the 6th power. It should become positive because it's an even power with a negative. And you get 64. When you type that in. Make sure you use parentheses with the negative. Alright, so here's a little trickier one. We have 9s and 4s, so I'm going to keep them with 9s and 4s. I'm not going to break them down. I have 9 to the 1st times 4 to the 5th. Again, you cannot multiply these numbers together. The only time you can multiply numbers is if the powers are the same, but they're not the same. And here I have 4 to the negative 5 times negative 3 is 15, and 9 to the negative 5. Alright, so here's the one where I want to show you what this negative exponent does. If it's on the bottom, all the negative exponent signifies is I'm moving this up here and making it positive. Okay, so this turns into 9 to the 1st times 4 to the 5th times 9 to the 5th. The negative exponent brought it back up over 4 to the 15th. And now we can use our power properties. We have 9 to the 1st and 9 to the 5th on top. If you multiply the bases, you add the exponents. So we have how many 9s on top? We have it to the 6th power now. Here you can subtract, or you can think about, well, which one's bigger? There's 15 on the bottom and only 5 on top. You can cancel out and be left with 4 to the 10th power. Now, if you type these up in your calculator, you get very big numbers, so we're going to leave it like that. Big numbers. We don't want to actually write them out. Okay, because it's 5 or more. Okay, let's go to the back. So let's simplify. Now these are without number bases. It's the same principle though. This means I can distribute or multiply power to a power here and power to a power. So I get a to the 6th over c to the negative 9th. We can't have negative exponents as our final answer. So this one down here will come up and become positive. So my final answer is a to the 6th, c to the 9th. Okay. This one's a little different. This negative sign is like a negative 1. So what we're really doing here is saying negative 1 to the 5th and y to the 10th. All I did was I distributed the 5. I'm raising that, which this won't change anything. It'll still be negative. And then I still have a y squared and a y to the negative 12th. Now if I just look at these three things, they're all the same base, so I can add all the exponents together. And if I add all the exponents together, I get negative 1 to the 5th, which is just negative 1. I don't know why I keep writing to the 5th. And then y to the, if you add these together, you get 0. Anything to the 0 power is 1. So that means that we get negative 1 times 1, which is just negative 1 is our final answer. No variables in that one. Okay. All right. Here, I'm going to distribute the bottom first because I can. There's no plus sign. R cubed s to the negative 3. So these are a negative exponent, so I'm going to bring them up and make it positive. And again, if it's a negative on top, you bring them down. So that's how the negatives work. I get r to the first over r cubed. And then on top now I have s2, s3. These balance or cancel. You have 1 on top and 3 on bottom. So if they battle, you lose 1 on each and you're left with 2 on the bottom. On the top you have s to the 5th over r squared. That is okay. There are no negative exponents, so we are good with that answer. Okay, so be careful with these. Some people just think that they have to raise the x to the 3rd power, the x squared. You have to raise the 3 to the 3rd as well. 3 is a different thing than the x squared. And that's x to the 6th over 6x to the 5th. So we get a 27x to the 6th over 6x to the 5th. Just math frac these. You can take a 3 out of both of those. So you get a 9 out of 2. And then there's 6 on top, 5 on bottom. So there's 1 left over. Do you need to put the 1? No, you could just say 9x over 2. All right, a little bit more complex of problems. Again, I'm going to distribute the power first. 8x to the 8 times 7 is 56. Y, 8 times 4 is 32. Y to the 30th over x to the 30th. So, since it's multiplying, you can just cancel if you can cancel. So we have 30 on top, 32 on bottom, which means we're going to be left with a net of 2 on the bottom. We have 56 on top and 30 on bottom. So if you subtract those, there's more on top. So you get 26. That's the final answer. Can't do anything else with that. Now this one, there's two ways to approach it. You can either distribute the negative 5 power to everything, including the two numbers, or because the whole thing is negative, you know it's going to turn everything the opposite way. You can just flip the whole fraction and then make this now a positive power. Because this whole thing was negative, so you can flip, so everything on top will go to the bottom, everything on bottom will go to the top. Now you can distribute, you get 2 to the 5th, k to the 15th, and m to the 9 times 5 is 45, over 3 to the 5th, k to the now 25th, and m to the 40th. Okay. 2 to the 5th is 32, 3 to the 5th is 243. Can't do anything with those numbers, you just leave them. We have 15 k's on top, 25 on bottom. If you cancel out what you can, you're left with a net of 10 on the bottom. And if you cancel out here, 45 over 40, you have an m to the 5th power. And that is the final answer. Okay. I know I went kind of fast with this, but this is the beginning of just simplifying exponents. We're going to start working with rational ones tomorrow. But yeah, hopefully this kind of makes sense because you've seen some of these things before. Really, the negative exponents are the only thing I think that are a little bit more different. So, all right.